Here we're going to continue with the explanation of the Arduino code, and then I made a LabView block and front panel using just the formula node because I wasn't sure if this was actually a requirement. There was two sets of instructions, and one said that it had it and one did not. So I just did it anyways, nothing too crazy. So we have a loop function, void loop right here. Compute temperature, void loop. It continuously reads the sensor. Compute temperature, where is that? Oh, right here. So it continuously reads the sensor and computes temperature, and then serial print, it prints everything to the OLED, and it has a loop delay. That's basically that. And then there's the serial monitor that displays the temp or the calculations continuously. And then there's also a serial plotter. And if I put my finger on the thermistor, it will rise. All of them. And then it should drop when I let go of it. Okay. And then this Arduino or LabView setup. Okay, in the LabView we have the front panel. This is the block diagram. There's the front panel. It's separate from the ESP232 hardware and is used to verify the thermistor calculations using the same measurement model from the Arduino code. There's inputs, the ADC value, reference, fixed resistance, the temperatures, roll, and then the beta and offset. The inputs are the analog to digital value, reference voltage, and all that stuff. The front panel displays each calculation. Or displays each calculated value step by step, the voltage, current, thermistor, resistance, roll, and calibrated temperatures. They are calibrated to Fahrenheit values and the final temperature result after applying the correction offset. And then the block diagram. We just use a formula node to implement the equations directly. This makes the LabView model match the Arduino code more clearly. In the left side of the formula node, these inputs are wired to the formula node. They are the same constants as the sensor parameters used in the ESP32. And you see the voltage equals the digital value times the voltage reference divided by the 4095. We have the current, and then the thermistor resistance is calculated, R therm, and our beta equation. And why it differs from our, we have 65 and then 66 and 66. Oh, we're getting close. LabView may not match because it's not it's not using like my actual ESP32 sensor data. This is kind of like a simulation, whereas the ESP32 has got real sensor data. The small differences are expected because of the analog to digital conversion noise, voltage rounding, thermistor tolerance, and the beta equation approximation. Overall, the LabView VI verifies the same calculation process used by the ESP32, and that ADC value to the voltage, to the resistor, resistance to temperature, and final calibrated temperature all roughly match, with some margin of error. But that is basically my explanation of the code and LabView and the physical demo finished.